topics. We are going to understand here M30 mix design. Simply we can write this M30. Here we deduce that M refers to mix and 30 is the characteristic compressive strength. Characteristic compressive strength of concrete in 28 days having unit Newton per mm square. There are several other mix like M10, M15, M20 and so on. It may vary M200. Here we see that M20 it have some specific ratio, that is 1:1.5:3. It is given by a particular formula which is 1:n:2n. Means it is the ratio of cement ratio, sand ratio, aggregate. Okay. We can say that sand is just double, sand is just half to the aggregate. Similar, if we further extend to the other mix, that is M25 and M30, up to M25, it can vary the different ratio, but if we go further M30 or other mixed design, then other mixed ratio, then we use mixed designs. Okay. We go through the mixed design. There are several codes used in the mixed design procedure. We will study here one by one. Simply, important code is 10262/2009. This is the code for mixed design. Another code is IS. These all codes are refers to Indian standard. IS 456/2000. By using this code, we can get all these things like water information about water cement ratio, the quantity of cement, and exposure conditions. Exposure conditions means atmospheric condition, the placing of concrete. Okay. Another code is used IS 383/1970. This gives information about C1 analysis. This test is performed for gradation of aggregate. Okay. It is the most important part of the mixed design. Another code is used IS 9013. That is the code for accelerated curing. Accelerated curing. We will further study about in deep about accelerated curing. Another is 9103. It is the code used for chemical admixture as well as mineral admixture also. Mineral admixture also. For chemical admixture and as well as mineral admixture in the mixed design. There are several codes like this. Another code is IS 516 1959. This code is used for calculating the strength such as compression strength, flexible strength, and splitting tensile strength test. Tensile strength test. Another code is IS 2386 1963 part 3rd. This code gives the information about bulk density, specific gravity, and void ratio. As well as moisture content also. Before understanding the procedure of mixed design, we must know that why mixed design is done. Answer is so simple. It is similar phenomenon as that I ask a question that why a company appoint an engineer. The main motto to serve a company as an engineer is, number one, to make the project economical, and we can't say to make the project durable, to make the work easier or workable, and to work as Similarly, mixed design is done because of to improve workability at given water content, to improve the strength. Third one is to make the project economical, because we can calculate exact quantity of material at an accurate proportion in the mixed design. And last one is to reduce the water content by using admixture. In case mixed design, we can say mixed design is totally trial basis. Before proceeding, we should well known about trials. Trials are basically changes in the water cement ratio, that is, and volume of coarse aggregate, that is gradation. To achieve a required slump, that is workability, in case of fresh concrete, and strength in case of hardened concrete. In that case, if we are unable to get required strength and slump, then another trial with different water cement ratio and different volume of coarse aggregate should be done. Mixed design of M35 grade of concrete. The main aim of mixed design is to find out the exact quantity of material used in making concrete in kilogram per meter cube. Means we have to calculate all the material which we are using in this mix in kilogram per meter cube, in cubic meter design. First of all, we should know all the following data which are given. In this mixed design, we are using cement grade of OPC 43 grade. Specific gravity of fly ash, it is conducted by testing, and this is confirmed by IS code, that is IS Indian Standard Code 2386 1963, and this is given in part 3rd, and this can be performed by using kerosene except of water. Similarly, because of this is a fine material, or all those fine material which we use in this mixed design are performed by water, by kerosene except that water. Okay, now admixture used,
here we are using naphtha based superplasticizer, and it is confirmed by Indian Standard Code 9103. Specific gravity of fine aggregate, that is Fa, it is also performed by experimental performance, and it is adopted by at that time 2.62, and it exists in John second. Here we have to know, we should know that all Rajasthan, all area of Rajasthan which exist in John second. Indian Standard Code 383/1970, and for finding the zone of aggregate, and it is followed by table number 2. Simply we can say that specific gravity of coarse aggregate it is also performed by experimental performance, that is and it is adopted by 2.65. It is also confirmed by Indian Standard Code 2386/1963 part 3rd, and it is performed by using water because it is a coarse material, so we can perform by using water and simply calculate the specific gravity of given aggregate or given material. Here we are using atmospheric condition, and in very severe atmosphere. This is confirmed by IS 456/2000. It is followed by table number 3. We can also see in the picture view in this table. Here we can see that there are several exposure conditions, environmental condition such as mild, moderate, severe, very severe, and extreme. These are the conditions of atmosphere in which we have to place the concrete. Here we can see that very severe, it is a condition of concrete surface exposed to seawater spray and corrosive fumes, or severe freezing condition, in which it is the condition in which we have to place the concrete. Now let us see that the mixed design, actual mixed design is shown by this target mean strength, and we have to achieve this target mean strength. It is different from characteristic compressive strength because it is a theoretical strength, and formula is given by F-CK equal to FCK plus 1.65 capital S. Here capital S is the standard deviation, and it is confirmed from table number 1. It is table number 1 is show in the revised edition of this code, that is IS 10262/2009, and it is shown in their previous edition in 10262 in 1989 in table number 8. Okay, then we can see here the standard deviation. Yes, it is assumed that for M10 and M15 grade of concrete, we have to use this standard deviation, that is 3.5, and unit of this standard deviation is Newton per mm square. And for M20 and M25 grade, we have to use 4 Newton per mm square, and before and after this up to 50 grade, we have to use 5 Newton per mm square. This standard deviation may vary, and that is we can see this in this note that tell us that the above values correspond to the site control having proper storage of cement, weigh batching of all materials, control addition of water, regular checking of all materials, aggregate grading and moisture content, and periodical checking of workability and strength. Here it is said that if we are use these precautions given in this note, then definitely we can use this standard deviation as 3.5, 4 and 5. But if it is not under process, then it may vary 1 Newton per mm square, that is given here. Where there is a deviation from the above, the value is given in the above table shall be increased by 1 Newton per mm square. Okay. Second point is we have to calculate water cement ratio, and here we are assuming 0.40, and it is confirmed by Indian Standard Code 456/2000, that is code for RCC, reinforced cement concrete, and it is followed by table number 5. We can also see in this table, in the picture view, table number 5. Here we can see that there are several grades of concrete, and in different atmospheric condition. For plain concrete, exposure conditions are belongs to for plain concrete and reinforced concrete, that is RCC, and it is PCC. Here different data are given, that is minimum cement content, that is for mild 220 kg per meter cube, and maximum free water cement ratio. Here we concentrate on reinforced concrete, that is RCC, and we are using very severe condition. Then we can see that we have to use minimum cement content here at least 340 kg per meter cube, and maximum free water cement ratio, that is water cement ratio, we have to use maximum 0.45, but we can use below this as we wish. And minimum grade of concrete we have to use M35. So we are using we are constructing here only M35 grade here. Adopted maximum water cement ratio in this mixed design we are using that is 0.40, and it is below 0.45, so we can easily use. Okay, third point is selection of water content. Now we come to our next point, that is selection of water content. Water required for 1 cubic meter given material is 186 liter as per IS recommendation, IS code 10262/2009, and we can refer this given water from table number 2. We can also see in this picture view here the nominal maximum size for aggregate for 20 mm we are using here, and then maximum water content we will use 186 liter, and we can say in this 186 kilogram. But by this quantity of water we can get only 25 to 50 mm slump. If we require 100 mm slump, that is for pumpable concrete, means at this slump we can pump the concrete for multi-stories. So it is recommended that each 25 mm increment in slump we have to use 3% additional water in the concrete. So as per our design, water content will be 186, water content will be 186 plus 186 into 6%, and further we can calculate. This gives 197 liter of water that we are using in this selection of water content. But this additional water decrease our required strength. Therefore, reducing this water, we use admixtures. There will be several types of admixtures we can use, means chemical admixture or mineral admixture, and can reduce the water quantity of water up to 20% and above. This percentage we can confirm by using several trials for different percentage. Water content, it is confirmed by Indian Standard Code 10262/2009. In this code, it is given that 197 liter as per code water we have to use in this mix design for per cubic meter volume. But for 100 mm slump, it is this data is given for 50 mm slump, and if we increase this slump up to 100 mm, then 20% reduction is allowed. And after 20% reduction, this value decreased 197 multiplied by 0.80, and it is decreased by 158 liter. So now we extend up to our next point, that is for calculation of cement and both combination of cement and fly ash. It is known as cementitious material. That is cementitious material, calculation of cementitious material, and it is given by weight of water upon weight of cement. It is the water cement ratio. And if we have to calculate cementitious material, that is weight of, if we said that weight of cement, then weight of water divided by water cement ratio, it gives the cementitious material in per cubic meter. Here we can see that 395 kilogram per meter cube it is achieved after using this formula. Minimum requirement of cement as per IS Indian Standard Code 456/2000, it is given in this code. We can see in this code in picture view in table number 5. It is the minimum cement content, and here for very severe condition it is given that 340 kilogram per meter cube we have to use in any circumstances. So we use 340 kilogram per meter cube of cement in this design. Then total cementitious material content is equals to this is 395, that is cementitious material, quantity of cementitious material, and multiply by this 1.10, means 10% increment is doing here due to early setting. Then quantity will be 435 kilogram per meter cube. Here water content equals to, this is the total quantity of cementitious material 435 multiplied by this water cement ratio 0.4, and so therefore water will be 174 kilogram per meter cube. That is our given cementitious material quantity. It is adopted in this way that cement is initially alone, and we are adding additional fly ash to make cementitious material. So water content we will use here 174 kilogram per meter cube. All our design will be conducted for cubic meter volume. So each quantity we are showing here, we can see that in meter cube. Next, fly ash. Here we are adding fly ash in the cement at the rate of 30%, but it is allowable as per recommendation of code 35%, but we are using here only 30%, and so the quantity of fly ash in meter cube will be 435, that is the our cementitious material multiplied by 0.30. It is calculated by 30%, and fly ash will be 130 kilogram per meter cube. So it is we can say that here we will see here that it is economical to that we are using if we will use total quantity of cement And if we use fly ash except of cement OPC, it is 435 minus 130, that is equal to 305 kilogram per meter cube. Here we can say that the saving of cement is exist, and so we can calculate this saving as per code and as per design. That is 395 minus 305. 395 is the total cementitious material, but we have to use the extra 10% due to increment of early setting. It is as per code recommendation. We can change this percentage as per code and by experimental performance, and it is totally trial basis. So we can say that the saving of cement is equals to 395, this is 395, and minus 305, this is the cement quantity in cubic meter we are using. So saving will be 90 kilogram per meter cube. Then we can say that it is economical to do mixed design. Okay. Here percentage of volume of coarse aggregate we have to calculate. Here we are assuming 0.59, and percentage of volume of fine aggregate, if we subtract this quantity from 100, then we can achieve 0.41. It is also done as per IS code 10262 2009. We will see in PDF in our next video. Here I want to say that generally ratio of coarse aggregate to fine aggregate is taken as 0.602 for coarse aggregate and 0.40 for fine aggregate, but here we are using 0.59 and 0.41. That is what we have to change this ratio to get required strength. It is also known as definite proportion of coarse aggregate to fine aggregate. Because of this, we have to do gradation of aggregate by sieve analysis. Then calculation for coarse aggregate and fine aggregate. Here volume of concrete we are using in all our mixed design is 1 cubic meter. Means all material we will have to calculate in this mixed design should be for 1 cubic meter volume. That all materials like cement, aggregate, fly ash, water, etc. Second point B, that is the volume of cement, and it is calculated by 305. It is our quantity of cement, OPC cement, which we are using, divided by 3.15. It is the specific gravity of cement, and multiply by 1/1000. So here formula we are using the volume of cement or volume of any material equal to gamma S upon gamma W. Gamma is the total weight of material we are using, and divided by specific gravity of water, in which in this respect we are calculating the specific gravity of any material. So calculation gives 0.096 meter cube, that is the volume of cement. Similarly, we can say that C point, it gives the volume of fly ash by using the formula, same formula which we have discussed. And last B, 130, it is the quantity of fly ash in cubic meter, divided by the specific gravity of fly ash, multiplied by 1/1000. It is the quantity of specific gravity of water, and this calculation is in respect of specific gravity of water. So we can easily calculate the volume of fly ash, and it is 0.059 in this case. Next, D is the volume of water, which is similarly calculated by 174, that is the quantity of water in liter per cubic meter as per our design, divided by 1, and divided by 1 means it is the specific gravity of water. and similarly here we are using the formula as above and get 0.174. This is the volume of water. Next we can say that our volume of superplasticizer we are using here a special type of superplasticizer in this mixed design. There are several types of plasticizer we can use, and we are using here SP431 grade of plasticizer, that is the superplasticizer and chemical admixture to improve the workability. It does not affect the strength of the concrete. So we can easily calculate the volume of superplasticizer by using this formula, as we have discussed above portion. And this is the 1.145 is specific gravity of superplasticizer, and calculation gives this value 0.0037. Then we come to our next point, that formula for volume of all in aggregate. Here we are calculating the aggregate of volume of aggregate, which is coarse aggregate, which may be coarse aggregate or fine aggregate. So small f equals to bracket 1 minus bracket b plus the summation of all above A, B, C, D and E, all volume of all materials which we are using in this mixed design. So volume of all in aggregate is equals to 1 minus, after putting the all values in this formula, we can get this value 0.67. We have obtained here mass of coarse aggregate. We can calculate this mass by using these values, that is 0.667 multiplied by 0.59. 0.667 is the volume of all in aggregate, you can see here, and 0.59 we have assumed this percentage of volume of coarse aggregate, and multiply by 2.65, that is the specific gravity of coarse aggregate. It is it is used by experimental view and multiply by 1000. This gives all mass of the coarse aggregate which we use in this our design for 1 cubic meter mix. Quantity will be 1043 kilogram per meter cube. So mass of fine aggregate, it is also calculated by this formula 0.667, that is the volume of all in aggregate. It is the volume of all in aggregate means it is the mixture of fine aggregate to coarse aggregate. Multiply by this 0.667, 0.41 is the volume of percentage of volume of fine aggregate which we have used in our last calculation, and multiply this value by 2.62. This is the specific gravity which we can calculate by using experimental view, and multiply by 1000. It totally gives the value 717. It is the mass of fine aggregate. So this is our totally calculation of final mix, and our sample is ready for first trial mix. So quantity of 1 cubic meter, quantity of all materials in 1 cubic meter, that is cement, equals to 305 per cubic meter, kilogram per cubic meter, and fly ash will be 130 kilogram per meter cube. Fine aggregate, this is we have calculate 717 kilogram per meter cube, and coarse aggregate 1043 kilogram per meter cube. Water cement ratio we are using here 0.40, water 174 kilogram per meter cube. This quantity of water we have calculate in liter, but for calculation, but for trial purpose we are using here, we will use in kilogram. And admixture of dose 1% we are adding in this mix, and it is calculated by the 1% of total cementitious material, that is 435, and 435 1% of this 435, it is given 4.35 kilogram per meter cube. This is the our total material which we will use in this trial mix. So it is ready for trial. Thanks.